Today we're checking out EcoWorthy's 60 amp battery charger to see if this might be a better option than maybe EG4's Chargeverter. I recently just bought this at about $300 depending on the time that you find it, versus the EG4 Chargeverter is around $600 or more. Now this doesn't put out as much power as this only puts out 3200 watts versus 5000 watts of the EG4 Chargeverter, but still, is it a good unit? We'll stick around for a few minutes as we do some testing, and then at the end of this we'll see if this is a good option for you.
When you get this out of the box, this is what you'll see is your user's manual, also a 240 to 120 volt adapter, along with a communication cable that will work with EcoWorthy batteries and probably these other smart batteries. It will also come with mounting hardware along with your positive and negative cable, which is 10 millimeters or about a 7 gauge wire, and also the AC cord, which this will be a L14 30 amp plug, and of course the charger itself rated at 60 amps. Now this does have a breaker on the side of the unit. On the other side you will have Wi-Fi and other communications, while on the back of the unit shows all of the specifications. When we turn the unit on, you'll see that it does have a black and white LCD display. Now this will automatically start to just run through all of the settings on the left side. You'll see as it goes through amperage and also the power that it's putting out. It will start up on manual, so nothing is going to happen unless you have it set. As we go through the functions button, this will be your charging amps, and we can easily go up or down by just pressing the button and holding it. It'll cycle all the way around to the other side as well, which is actually kind of a nice feature. As we continue to press the enter button, this will show us our battery charge voltage, which this is adjustable along with your floating voltage, and then as we continue on, this will give us a set of timers, which is actually kind of nice. We can actually do a countdown timer or set it for a certain amount of hours, which this does become handy because sometimes I only want to run something for 3 to 4 hours. And the last setting will be setting up your battery chemistry like lithium iron phosphate, AGM, or lead acid. When looking at the display at an off angle, it is a little bit harder to see as you can't see what you have the settings at until you get pretty much straight onto it, so this is just something to note. And then finally we come to the on-off button, which you will see it go from manual to auto, and then also the charge light turn to green, and you'll see the arrows starting to say that it is charging. Now while this unit is just plugged in, it will use about 45 watts of power while not doing anything, but the supplied power may use over 50. Now when it comes to turning this unit on, this is when you will see the power draw go up more, even though it's not doing anything and just on standby. As we can see now, our supply wattage is higher. We're now going to plug this in using these PowerPole cable connectors. I'm going to plug this directly into my 48 volt batteries using these. This is something I conjured up a while back so I can have a direct connection to my battery, so I can either put power in or draw power out directly with DC. As we take a look at the app, you can see the current battery voltage of my setup at 53.6 volts. As we take a look at the charger, it does say 53.8, so I'm not really going to worry about a 0.2 difference. We'll now hit the power button to turn this on, so this should start charging the battery, and that way we can start doing some testing. I'll be checking fan noises, also heat as well, and we'll also get some thermal imaging. So we'll turn this up to 10 amps and come back in a couple minutes. Okay, it has been about 5 minutes and the fan is now on, and we are still putting out about 10 amps, which this is around 530 watts that are pumping into the batteries. Now your supply, which could be a generator or maybe a power station or whatever it is going to draw a little bit more energy, like around 600 watts for that 530. This is going to be the exhaust side of the unit where all the hot air is going to come out, which I can feel this now starting to get warm. And this will be the intake side of the unit where it will pull in the fresh air, which this does seem to move a decent amount of air, and it is a little bit noisy. So as we get our dB meter out, you can see it's about 64 decibels, around 68 on the intake side, but this is only about 10 inches versus right here I'm about 3 feet away, and this is much more acceptable. But it's not something I would just want to sit next to. We're now going to bump this up closer to 40 amps and also to see if the fan speeds change at all. And as we take a look, 40 amps will provide about 2180 watts going to our batteries. And if we look at how much draw from, say, a generator or again a power station, about 2350 watts for the 2180. We're now going to bump this up to the full 60 amps, which I don't recommend any piece of equipment being used at its full capacity, but for testing purposes, we can see it's putting out 3200 watts, but it is drawing about 3500 watts from the supplied power unit. When it comes to the fan noise, it really hasn't changed. It seems to be one fan speed once the unit is on. As we take a look at the temperatures of the exhaust temp, this is 105.6 degrees, as this has been running for over 20 minutes during this test. I ran this just to make sure that nothing would overheat, as it is about 76 to 78 degrees in my garage right now, and we are still putting out 3200 watts. As we take a look at this thermal imaging just to see if there's anything that is excessively hot, so far it looks like everything seems to be within reason as we look at the cables supplied by the unit and then my cables as they go over into my batteries, and then that's just a jumper in between both of the batteries. Now when it does come to using a generator, that supplied cord actually didn't work because they didn't wire this correctly. They actually messed up as there is no neutral. We need a load wire and a neutral wire because these generators are floating neutral to get the 120 volts needed. I decided to take the plug apart just to make sure I wasn't doing anything wrong, and my suspicion is correct. We have 2 load wires and only a ground wire, which we need a neutral and 1 load wire. That way we can use a 120 volt source. If we look at this adapter that I made a long time ago for the EG4 unit, this side here is the load, but I need the neutral to be on the opposite, while the W is the neutral. So I bought this adapter for around $15 to $30 and some wire that I already had laying around, along with this other adapter so I could use different types of generators. So now when we use this adapter that I made, you can now see the eco-worthy product works. So it ends up being to where the other adapter that is supplied is kind of useless, so you will have to make your own adapter. But this now allows you to use a 120 volt source like several different types of generators.
Okay, so what do you think about the eco-worthy battery charger? Obviously, the major flaw is this guy that they include, which obviously doesn't work, so it becomes really just a waste, and you have to make your own adapter. But you still could use this one. You would just cut off this end, order one of these, which isn't expensive, about $15 to $20. If you buy the better ones, they're about $30 to $40. And then you would just chop off this side, then strip it down, make a connector like this one, and then you can use the 120 volt. So that was really the big flaw that deterred people from buying this, because they saw some bad reviews, so hence I was curious. But at half the price of the EG4 Chargeverter, it seems like it still could be a viable option. Let me know if you guys would like to see a head-to-head battle with the EG4 unit as well, and I hope you guys liked the video, and I hope to see you in another one.